In this video, I just want to talk very briefly about single crystal diffraction as opposed to powder diffraction, which is what we're going to cover mainly in this course. So in a previous video, what we talked about was we said how if we've got a crystal structure and we pass, for example, X-rays through it and we get diffraction occurring, we're going to get discrete diffraction points corresponding to the reciprocal lattice. Now what this means is if we take our crystal and we have a single crystal and we put it in a certain orientation, then we're going to get a pattern where we can see the diffraction occurring from certain planes in the crystal. Certain planes will be in the right orientation to diffract, but not all of them will be in the right orientation to diffract. So what we get is something like that shown on the left here, is if I've got my crystal in a certain orientation, I would see certain diffraction spots because certain planes are in the right condition to diffract. We'd have planes lining up in that direction, for example, which would then help us to produce diffraction spots shown in this pattern out here. But we wouldn't get all diffraction spots corresponding to all planes because certain planes would just not be in the right orientation. What we therefore have to do is rotate our crystal in order to then bring certain diffraction spots into the right orientation in order to get diffraction occurring from them. And this is what we do in single crystal diffraction experiments. Very often we use something that's called a 4-axis diffractometer, where we load our crystal, we're then putting X-rays through it, but then we have to rotate our crystal in certain directions in order to get diffraction. And I've just got a little cartoon to show what happens here. So imagine I've got my crystal in a certain orientation and I shine my X-rays through it, and so I'm going to get diffraction from planes in that crystal and I get certain diffraction spots produced. I then have a detector that's just on a single arm moving in a single arc round that material. So I would move my detector in that single arc and I would measure the diffraction spots that I get from that crystal in that orientation. What I then do is I rotate my crystal, and that would essentially rotate my diffraction pattern that I have on the screen as well. And I then would move my detector around in an arc round here and I'd measure the diffraction spots that I'd get there. And so I'd gradually build up a picture of my total diffraction pattern. Now that's obviously useful and helpful and a good way of doing things, and allows us to build up this complete diffraction pattern if we have a single crystal. However, very often we don't have a single crystal. Practically, we might have something that's polycrystalline that has lots of crystals within it, and we still want to get usable information out of it. So what happens in that case? Well, in that case, what we can think of is rather than having one crystal with a diffraction pattern in one orientation, we've got lots of different crystals in lots of different orientations. So what does this do? Well, imagine I've got my reciprocal lattice that I'm showing here, showing where I'm going to get diffraction occurring, and I would see those discrete diffraction spots occurring within my diffraction pattern. What I then might think of is, well, what would happen if I were then to rotate that, have a crystal that was a second crystal that was at a slightly different angle? And what that would produce is it would produce a diffraction pattern that would sort of overlay, where I get another diffraction spot which would be slightly offset from the first diffraction spot. And I could carry on adding crystals in all different orientations which would overlap, and eventually what I'd get is, rather than getting single diffraction spots, I'd get a ring of diffraction, a ring of diffraction occurring because I had crystals in all different orientations. And so in fact what I see when we do a powder experiment is you get these rings of diffraction occurring, and generally in fact what we can think about is we can have cones of diffraction coming out of my material corresponding to all of those crystals in different orientations producing that ring of diffraction from a certain family of planes. And so now, rather than needing to rotate my crystal in 3 dimensions and then scanning around in a certain dimension, what I can do is basically I've got all crystals in all orientations, so all orientations are sampled equally, and so therefore I only need to scan around in 1 dimension, and so I reduce my powder diffraction pattern to just a single dimension. So I've reduced my three-dimensional information just to one dimension, because now all I need to do is essentially scan out in a single direction, because I've spun that single crystal pattern round, produced those rings, and then I just need to scan out in one direction in order to produce this scattering pattern that I have here, my my powder diffraction pattern that I'm showing on the left here. But the key thing to note here is that we've made the assumption that my material has crystals in all orientations. And that's not necessarily going to be true for a real sample. A crystallographic powder means that I have crystals in all orientations. But very often when I have a real sample, it might be that I have crystals that are in certain orientations, in certain preferred orientations as it's called. And this produces what's called texture in the sample. So you might hear people refer to either preferred orientation or texture, which means that we don't have a true crystallographic average, but instead certain crystals are aligned in certain directions preferentially. And that's going to have a key effect on our diffraction pattern, which we'll discuss in more detail later. But the key thing to realise here is if we have a powder, and generally in this course we're talking about powder and powder diffraction refinement, is we're going to get this one-dimensional diffraction pattern where I've got these crystallographic peaks corresponding to those diffraction spots in my material.